Okay, the big amount of work that we did in version 2 dealt with part 6. Now, part 6 is broken into multiple pieces, and in fact, we're releasing some of the pieces we've already just announced, and then during 2020, we'll be releasing a couple other pieces. I'm going to talk about 6.1, which is the first part on it. It really defines that standard import-export configuration file. The whole purpose of version 2 was portable configurations. So to have portable configurations, we got to have a standard format that any certified vendor will be able to import, make whatever changes they have, define their tags, define their programs, their function blocks, define any of the other information, alarm information, et cetera, and be able to export it back out in a format that others would understand. So it's a standard import-export configuration file format. It's based on automation ML. Any of you are familiar with MTP, you're going to see a lot of familiarity here of what we're doing. We define a standard import package file structure. Okay, so it's not just one file for a project file. It actually contains multiple things. So you may have the source code from your 1131 program, along with the definition of your tags, along with the definition of 1499 and alarms, et cetera. And we use a compressed file format, which is based on the open packaging convention. Basically, it's the same stuff that we use in the IT world. If you open your doc files and change it to a .zip or docx file, change the extension to a .zip, you'll see this actually all zip files. It's exactly the same sort of technology, which is already out there. Lots and lots of software that already supports that, so we wanted to use it. We defined a standard upload-download structure for the downloadable files. Now remember, we're talking common and portable configurations, but part of the configuration is what has to actually go down to those devices at some point in time. Now, we're not defining the format that goes down to it. What we're defining is a way to store it in these compressed files, and then also a way to upload and download those files. So for example, let's assume that you have a system which is built and it may have 5 different vendors, DCNs that are out there that need to work together. What you want to do is you want to control the download of your application, which might be distributed across those in a common format. So we have a common set of upload and download services, and again, these are using OPC UA to allow you to download to all of these different devices. The download services and the definition of it also have a specification of multiple environments in a DCN. One of the biggest problems that we often have with the systems and the control systems is you can't take it down to do an update, to do a change. So using a lot of the models that existed in some companies like Dow and others, we basically say we have multiple environments. I can be running one environment and downloading to the other environment. I can turn it on to simulate or watch to make sure that there are not changes, and then provide a mechanism to switch over my environment. So I don't have to shut down my system when I want to do updates to my applications and my configurations. And then finally, we have services, again, OPC UA services, to actually control the applications, the function blocks and the applications, to turn them on, to turn them off, to pause them and control them in a common manner. So that, again, we're trying to apply what Dave DeBerry has called the systemness to the problem space, so that this thing operates like a system. So I can download to all my devices the same way, so I can download and switch over environments the same way, so that I can control the function blocks. So to give you some idea of what this looks like, and again, it's very difficult to read the small things. It's pretty much impossible to read these here, but you've got something which is essentially, as we said, it's a zip file. And within it, it contains an automation ML file. That automation ML file contains all the definitions of the tags, the DCNs, the execution engines, which are really the term that we're using for like the layer I applications, and all the other information that's out there. Those things, because of the way automation ML works, contain an external reference to the other files. So your automation ML file says for this DCN, it's running this PLC open IEC 1131-3 program, and here's the source file for it. And then from a vendor standpoint, they say, okay, I'm going to take that, I'm going to convert it to the binary for my DCNs today and put that back into that same zip file, that same project file. So we're controlling, that's the file format for the applications. This is basically saying, this is what people are going to import and export. This gives us the portable configuration capability. And then on the right-hand side, you see the state model for how do I control the applications. That they are operating, or they're in shutdown, or they're out of service, or they're starting up, or they're shutting down, so that I can, in a common way, control the applications and again, when I talk about the applications, I'm primarily talking about what we call the layer F applications, the top level applications written by the end users. How do I tell them to turn on, to turn off? How do I control those function blocks in those function block applications? So this is really what we've been doing to define the portable configurations as we move forward in the part 2 definitions. And now I'll pass it over to Vienne